Best rice farming practices strategy number 3. This is water management, the game-changing practice. Understanding why less water produces more rice. Perhaps the most counterintuitive and revolutionary aspect of SRI is that rice produces higher yields with significantly less water, typically between 25 to 50% less water than conventional continuous flooding, while simultaneously providing numerous other benefits, including reduced labor, lower pumping costs, deeper root systems improving, drought resistance, better nutrient intake, and reduced methane emissions, benefiting the environment. This seems to contradict everything you have learned about rice being a water crop that requires flooding. But understanding the actual relationship between rice plants and water reveals why controlled moisture management produces superior results. Rice is not actually an aquatic plant. It is a terrestrial plant that has evolved the ability to tolerate flooding, a trait that provides competitive advantage against weeds that cannot survive flooding. But tolerance doesn't mean preference. Rice actually performs optimally under moist but well-aerated soil conditions where roots access both water and oxygen, allowing robust root development, enhanced nutrient uptake, beneficial aerobic soil microbial activities, and efficient metabolism. Continuous flooding creates anaerobic conditions, restricts root growth to shallow depths, reduces nutrient uptake efficiency, encourages certain diseases, and wastes enormous water through seepage, percolation, and evaporation. The scientific basis for alternate wetting and drying, that is AWD, the water management techniques central to SRI, is well established through hundreds of research trials, demonstrating that allowing soil to dry to moist but not saturated conditions before irrigation stimulates beneficial plant responses without causing water stress or yield loss. During drying periods, when there is no standing water but soil remains visibly moist, rice roots grow deeper and more extensively, searching for moisture, creating root systems between 30 to 50% larger than enormously flooded systems, and accessing nutrients and water from greater soil volumes. The aerobic conditions during drying period enhances beneficial soil microorganism populations, including nitrogen-fixing bacteria, phosphorus sublimation bacteria, and other beneficial organisms that improve nutrient availability and plant health. The mild stress of drying triggers plants to produce more tillers, a drought avoidance strategy to maximize production success before conditions worsen, resulting into about between 40 to 80% more productive tillers per plant. Upon reflooding after a drying period, plants rapidly uptake water and nutrients, experiencing a growth surge that accelerates development and grain filling. The cumulative effect across the growing season is plants that are more vigorous, better nourished, more resistant to drought and diseases, and significantly more productive while using between 25 to 50% less total water. Here is how to implement alternate wetting and drying systematically. This is AWD implementation. Implementing proper water management requires understanding rice growth stages, observing soil moisture conditions, and irrigating strategically based on plant needs rather than fixed schedules. The general AWD protocol follows this pattern. After transplanting, maintain saturated soil conditions 1 to 2 centimeters of standing water if possible. For the first 10 to 15 days, allowing seedlings to establish without water stress. This establishment period is critical and should not be compromised. Once plants are established, showing vigorous new leaf production and beginning to tiller. Begin the AWD cycle. Allow standing water to dissipate through absorption and evaporation. Then allow the soil to dry progressively until small cracks begin appearing on the soil surface, typically 3 to 5 days after standing water disappears. Though timing varies with soil type, weather, and plant size. At this point, when cracks appear but soil remains visibly moist below the surface, re-irrigate, applying 5 to 10 centimeters of water returning soil to saturated conditions. Allow this water to dissipate and repeat the cycle. The practical implementation requires observation and adjustment rather than rigid schedules because the drying period varies based on soil type. Clay soils hold water longer than sandy soils. Weather. Hot, dry periods cause faster drying than cool, cloudy periods. And plant growth stage. Larger plants with more leaf areas transpire more water. Therefore, monitor your fields daily. Once standing water has dissipated, looking for the first small cracks appearing. This indicates soil surface has dried to approximately field capacity, but subsurface remains moist. Then irrigate within 1 to 2 days. You are aiming for the soil to never become truly dry, which would cause water stress, but to cycle between saturated and moist conditions. Providing alternating periods of aeration and moisture can stimulate beneficial plant and soil responses. Critical growth stages require special attention. During the reproductive phase, that is approximately between 45 to 55 days after transplanting, when the plants flower and form grains. Maintain more consistent moisture, avoiding extended drying periods because water stress during flowering reduces grain set and yield. During this critical 5 to 15 days, irrigate more frequently, maintaining saturated conditions. After grain filling is complete and grains have reached maturity, approximately 95 to 105 days after transplanting, depending on the variety, stop irrigating, allowing fields to dry for harvest. Maintaining standing water late in the season delays harvest, increases grain moisture, and may reduce grain quality. For rain-fed rice farming, where you cannot control irrigation, AWD principles still apply. Avoid maintaining continuous standing water if possible by creating drainage channels, allowing excess water to drain. Maintaining fields at moist rather than flooded conditions, whenever feasible, and understanding that the periods between rains when fields are moist but not flooded, period. The beneficial aeration that stimulates tillering and root growth. Many farmers worry that without continuous flooding, weeds will overwhelm their rice. But proper SRI implementation, including timely mechanical weeding, discussed next, provides effective weed control without continuous flooding, and the competitive advantage rice plants gain from proper spacing and vigorous growth actually reduces weed pressure compared to conventional systems.